so so let's get started on the. Let's do the first. Let's try the first problem. So what are you being asked to do?
Apply the formula to determine the measurements of the atom form. The top one corner of the prism to the opposite bottom corner, round to the nearest tenth of an inch.
Okay. What? So what are you being asked? What are you being asked to do?
What?
What are you being asked to do for?
Add all the sides.
Yes.
Yes, I
Now, what do you think? What do you think? What do you think you have to do for?
You add. I multiplied.
Okay, you add.
Add every single.
Two,
oh,
four, two,
like
two.
A squared plus B squared equals C squared.
Yes. Yes. How would you do that for number one? What would you get for the first one?
What's this called?
It's just 12 squared plus 4 squared plus A squared equals C squared.
Sorry, equals what?
Equals C squared.
15.
I mean, sorry, D squared.
D squared. Yes. Good. And now, can you just
Now rewrite it. So 6 squared plus. Do you have to divide, like, cut this in half?
It is, yeah, it's already in half. How would,
6 squared plus 2 squared plus 3 squared. Now we have to, like, multiply all, like, add them all together.
yes. Yeah, that's good. And now, what would you get for that?
144 plus,
You-
16
yeah.
plus, 81, no, 64.
Okay, and what would that be? That's fine. That's fine.
Okay, point
Make sure to show your work. Make sure to show your work here. No, that's fine.
Yeah, I just want to rewrite it.
Okay.
I just like put it in.
Oh my god, you just crushed it. Go get
Very
it.
good.
And then 9, 64. So now 4, 6, 10, 14. 2. You get 224.
Yes.
224 equals D square.
And then what would you
got
do?
a square root. And D here. So square root of 224 is
I bet what's square root of 224?
Yeah, just. What is the square root of 224?
square root of 224 is 4. Put it in, and then it's 15. 15 square root.
15?
It's 14.
14.96. Yeah, just.
But you round it.
Yeah.
14.9.
What does it say? Let's see. What does it say to round to here?
Nearest 10th.
Okay.
So it's 15.
Yeah. So do you feel like, how do you feel about rectangular prisms?
It's pretty easy.
How would you, I don't know, let's say if I were to give you, so let's say if this were, let's say, this were a 10, for example, 10.
Instead of 8?
Yeah, instead of an 8. Yeah, how would you, just, how would how would the way that you would approach finding volume change?
Change.
Yeah.
So the A goes away, right? So there's only 3. I mean, the same thing.
Yeah, well, like, can you tell me like the formula?
Formula? Just like 12 squared plus 4 squared plus 10 squared equals D squared.
Yeah. Yeah. Can you figure that out for me?
Mm-hmm.
If the 8 were a 10.
Yeah.
So let's
I could just like
try that out.
add that to like in the cat.
Yeah, you're doing well.
Um,
Mm-hmm.
254. We get 254, and then if you square root that, this should be like
Yeah. So since we don't have a calc, can we let's sure. How would you do that?
15.93.
Yeah.
So we could just say 16.
Let's say we round that to. Yeah, let's say we round that to what it says here in the round in the nearest tenth. So yeah.
16.
Well, if that is how you round it. Okay. So now I'm gonna give you. Now I'm gonna let's do a problem. Let's do a problem together. No, actually, no, I'm gonna do this problem. Let's say I do this problem for it would be 6 squared plus 2 squared plus 3 squared equals d squared. 36 plus 4 plus 9, and then what would that give us? So
3 squared.
what was we already? So let's see, 36. Let's show 36 plus 9 square root. Oh, this is perfect. So this is perfect. So it would be square root of 49, and that's actually perfect. I'm sorry, d squared. This 7 and d. So this is just a random example that I thought of for this one. And how about if I change it again to make it, let's do, instead of 2, I make it a 5. Let's say it's 5. Let's say it's 5. How would you find that?
6 squared plus 5 squared plus 3 squared equals d squared.
Good. Good. Do you get why that's how you do it?
Yeah. Because we have like the length times width times height. We have 3 numbers.
Yeah, and then what are you supposed to do with those three different numbers?
You just have to just put like them all before d. It's like all square, not minus anything, just square them and then square root.
Yes. So how about last question? Last question. Just another random one. I want you to explain. Let's say I draw this. Just a random question like this, and the number is going to be say 12, 5, and no. Let's do this one. 12. This. You get that it's big. You get that it's big. So let's say maybe solve these, because yeah, how would you solve these three? So if so these are rectangular prisms, if this side, this side right here is 10, this side right here is 7, this side right here is 6, how would you find this side, the hypotenuse? From what we just said.
So
That's the same thing.
10.
You can show you.
So this one's 10, right?
Let's do this right now.
Sorry, can we read it? So for this one, just
For all three of them.
probably like, I think it's like the same formula.
Yes.
I guess just 10 squared plus 4 squared plus 6 squared equals d.
And how would you solve that?
Solve that, like add all of them first, and then square root. So should I do it?
Can you show you up?
Yeah. So,
No, it's not us.
Black screen.
and then you just add all of them. 100 plus 16 plus 36. So you just get and then you get 161, and then you get 161, and then try to square root 161.
And then what you get for that one?
That's 12.72, so around 13.
Well, yeah. Let's say you can value. Let's say you want to do this whole number.
13. 13 units, I guess, or something.
Yeah, it could be units. Yeah. Good. And then for number 2, number 3.
Number 2, number 3.
Yeah.
So it's 5, 9, 7. Right?
5, 9, 7. Yeah. Yeah.
5, 9, 7. Alright. I guess, but then it's faster. Go 155. Then when you square root, 12.44. Also equals 13 units.
Okay. Nice.
Super.
There.
And then for the
Last one.
last one. For the last one, how would yeah, for the last one, how would you do that?
Same thing. 10 squared plus 5 squared plus 3.
Mm-hmm.
134. What's that? 134. And then you get 11.57. You just round it to 12. You say d equals 12.
Now, if you if this were if this box, let's call it a box. If this box were were like a shipping box, container box, how would the way that you round it change? Like what did you get for this one originally? for square root of 134.
Yeah. 134.
Yeah.
11.57.
Okay. So how would it change if you were given let's say on a test, if you're given a problem about, like a toy being in a box, and like how, why would you round it, just practically speaking, why would you round it to 12? Like any guesses?
To like see like if something like this inside or
Mm-hmm. And what would the point be to round it exactly to like a whole number?
I guess to like just make the math easier or something. Like for dimensions or something.
Yeah, to make it easier.
Yeah.
Because because think about how would people measure?
Yeah. Same thing as like simplifying it. Like people simplify big numbers to make them easier, but they still big numbers.
Mm-hmm. Yeah. Because in real life, sometimes you have to like round up, round down. And let's so now how last one, can you explain how you would, what you did here? What is your thought process? 1, 2, 3, 4. 1, 2, 3.
So basically, we took a squared plus b squared plus c squared equals d squared, and we have a 3D model. So we're trying to find. We have 3 sides, but by having all those squares, we could find like the whole 3D like rectangle, and then square root what equals like simplified of the actual like I guess like the rectangle whole like thing, what it's like I guess.
Yeah, that's good. So you just so you solve the triangle, and then you find the length, the width, or the height,
Or the hop.
or that yes, and then that would allow you to find what, to potentially find out what else.
Like the missing length or something. Like you could have something missing, you could find it like in anything, like maybe like centimeters, inches, cubic, or something, like minutes, or the Hopnatus that you can't really like could tell you through like this formula.
Yeah. So last one. So are you comfortable with finding like the volume, the volume of a rectangular prism, finding using the Pythagorean theorem to solve the triangles? Would you be able to do multiple examples?
Yeah.
Like not just these. Like, would you be able to label based off of a word problem?
Yeah, I think so.
So yeah, okay. So like you did here, and which one? Can you say which one? Let's say of these, which one would be bigger? Let's say this second one. I mean, this number 5 or number 6?
Number 6.
Can you show your work? How would you do that?
But you could like check like if you add all of them. Let's just say a plus b plus c. Let's just say this. You could just add them in square root and see which one equals more.
Perfect.
Like a squared plus 3 squared plus 4 squared equals 89. And then if you do that one, 2 squared plus 2 squared equals 5 squared. You get 93, so it's the same one, bigger. Even if you and then just square root.
So what did you get for number 5?
So,
Can you jot that?
you get 89, so it's perfect. Do 89.
Yeah, and then for number 6. And what would you get for that one?
You just get 90. But then you don't have to like square root. You can tell that this one is bigger.
Okay. Now, without even solving it, right? Just maybe by looking at these rectangular prisms, can you tell which one could be bigger? Like without it, if you just don't.
Not even. Not really. Can't really tell. Because like some numbers might have the same on each side, but one of them might be like 1 or 2 different. But yeah.
So why? So just in general, why would it be important for you to we just did use the Pythagorean theorem for 3 sides, and then solve, like do all this math? Why would that be important?
To see like
Like if you can't tell, you just said that you can't tell.
to find out like the actual right like measurement, like centimeters, units, or whatever it is, you can find out the right measurement. It's like could be like a box, and it could be like hollow inside, and you want to like fit a shoe box in there, but you have to like find a squared plus b squared plus c squared and see like the dimension and will it like fit or not.
Yeah, and that would allow you to be, you would know exactly which one is bigger. That's very good. Very good.